Radiology. First slide, first picture, what are the modalities? First one is USG. Okay, this is X-ray, easy peasy. This, now we have to differentiate between CT and MRI. In CT, C for calcification. Whenever we see bone that is calcified, that is white, it is CT. This is also 3D modality and it is nothing but rotating X-ray. So this one is having highest radiation. Whereas when I consider this is nothing but the scalp fat, which is white color. But the bone cortex is black. Bone is black. Hence this is MRI, which is also a 3D modality, but there is no radiation and it is expensive. Why is it expensive? Because of the the mechanism of action. Like, in a simple word, if I have to say, we are made up of protons. So the function of this is there is heavy magnets, 1.5 Tesla, 3 Tesla, and its function is to arrange the proton in one direction and create the magnetic field. Okay, so this is how the MRI works, and hence it is not running on radiation. Exposure is nil. Now let us learn the terminology. This is the basics of radiology, that is the terminology. Easy way to remember is, remember in the word of black and white, whatever is black, first let us differentiate between these four. When I say X-ray, since this is 2D, this is separate, these three are together. Okay, so the terminology which we use for X-ray, black is lucent and whatever is white we say as opaque. Done. And in CT, MRI, USG, whatever is black, we will be saying them as hypo. Hypo, hypo. Whatever is white, hyper. Hyper, hyper. Okay. Now in CT, remember the next alphabet D. So it is hypodense. MRI, remember the last word I. So it is hypointense. USG, you can say echogenic or echoic, hypoechoic. Done. Similarly, hyperdense, hyperintense, hyperechoic. One more terminology that we use in USG is when we see something which is known as jet black. Okay, when we see jet black, we say anechoic. This terminology is not there in CT and MRI. Anechoic is the terminology which is used only in USG. That is jet black. For example, this is a liver and a jet black fluid collection. It is anechoic. If it is only black, we say it as hypoechoic. Okay. So now we are done with the basic terminology. This is nothing but white. So it is CT. Here this is scalp, which is scalp fat, which is white, and this is the bone cortex. And I told MRI, bone is black, fat is white. Okay, so this is CT and this is MRI. This is nothing but fat and this is our cortex, bone ka cortex. This is how we differentiate between CT and MRI. Now third image, what is this? As I told, this is white. So whatever is white is nothing but CT. This is simple. Now coming to this. Here this, here the bone is black, this fat is white. Same, fat is white, bone is black. So both of these are MRI. But here you can see that the fluid present in this is the fluid press. Oh, I'm so sorry. Even this one is nothing but MRI. So when I say the fat is white, and this is the bone, the jet black, this is the bone. So this one is T1 weighted MRI. Simple. In MRI there are three. Okay, one is T1 weighted. T1 में this one is CSF is black, The gray matter is gray, white matter is white. Okay, simple. Here T2 में World War II in T2 CSF is white, gray matter is white, white matter is gray. So ulta pulta. Again this one it is not white, and so we'll think it of T1, but when we see gray matter is white, white matter is gray, hence this is known as flare. Okay, what is flare? See, it is nothing but the T2 weighted in which the CSF is removed. T2 weighted imaging, but when I remove the CSF, it is nothing but flare. Why it is used? Because see, whenever there is edema, edema is nothing but water. Okay, inflammation, edema, water. CSF is also water, so this guy is also white. This is also white. So what we do, let us eliminate the normal thing. So in T2 weighted image, if I remove the CSF, what left is flare, so that I can see edema properly. After that, third one, let us identify the sequence. This is the fat, this is the cortex, hence this is nothing but MRI. Starting from this is our ventricles. Okay, see, CSF is white, hence it is T1. Hence it is T2, that is World War II white water. Hence T2 weighted imaging. And when you consider here, what is happening in this T2 weighted imaging is, what is this present? This is nothing but the lateral ventricle, correct? So when you see the lateral ventricle, this is CSF, this is frontal part of it, this is occipital part of it. This is nothing but thalamus. The green one is thalamus. This next to your frontal part of lateral ventricle is nothing but caudate nucleus, very important. And this lens shaped is lentiform nucleus. So again, lens shaped, lentiform. This one is thalamus, caudate. This is the occipital horn. Clear? This is nothing but our MRI, World War II, hence I told T2 sequence. One more thing, this is lentiform nucleus. The lentiform nucleus, which is lens shaped, is made up of outer putamen, inner globus pallidus. This is the most common site of bleed in elderly with hypertension. The question, the most common site of bleed in elderly with hypertension is putamen. Then let us go to three sequences. 1, 2, 3. Midbrain, pons and medulla. Okay. So starting with midbrain. What is this? MRI. Because this is the cortex and our cortex is black. That is, bone is black. So it is MRI. After learning what is MRI, and you can see CSF is white. So it is T2 sequence of MRI. And when I consider midbrain, what is happening? Panda. Excuse me. So in midbrain, the identifying feature is panda. See, the eye of the panda is nothing but the red nuclei, and above it is nothing but substantia nigra. Deficiency is of this is seen in Parkinson disease. Here, easy identification, nothing much. When you see a panda like structure, just tell it's midbrain. Sequence you understood. Again, this is substantia nigra. This is nothing but red nuclei. And this, what is this? The fluid filled structure. It is nothing but the ventricles. This is nothing but our CSF. Okay. Now let us identify, if it is CSF, what structure is that? That is important. Whenever we study, first there is lateral ventricle. Just now we studied two lateral ventricle, followed by there is foramen of Monro, through which the CSF flows to third ventricle, through which is forced to aqueduct, sylvius of aqueduct, and then it goes to fourth ventricle. So this Chintu point in midbrain is nothing but aqueduct, sylvius of aqueduct. Done? Clear. So when I come to this is nothing but pons. The black structure is nothing but pons. How to identify pons? Just see the area front and back. Here you can see one black color void like thing, no? In MRI there are two things black, one is bone and one is blood vessel. Okay, since in blood vessel blood will be flowing fast, the magnetic field, we are not able to get signal and it comes as black. So this is which artery which is present in the prepontine region? It is nothing but the basilar artery. Okay, and this is diamond shaped structure with the white. What is white? CSF is white in MRI. World War II. So this is nothing but the quadrangle, yeah, diamond shaped fourth ventricle, the basilar artery. This is nothing but the vermix. This is nothing but cerebellar hemisphere. Don't tell it as pons or midbrain or something, because it is beneath that. We get first midbrain, then pons, then medulla. So this, after seeing the midbrain, I will get pons, then I will get medulla. And when I see midbrain, I have to remember that the CSF containing fluid here is aqueduct. Same when I go up, I see the structure that is nothing but the fourth ventricle. This is the last structure, that is medulla oblongata. What do we see here is nothing but easy. Just identify two tonsils, like the two tonsils, herniation of this, compresses on respiratory center. This is tonsil, this is nothing but the medulla oblongata. No stress, no much thing. Congenitally, if these tonsils are down, this is cerebellar hemisphere, are down, it is called Chiari malformation.